This time we'll have lesson 3.7, and it's about the properties of logarithmic functions. What do we expect in the class? We expect to solve for domain, range, y-intercept, x-intercept, zeros, and also the vertical and horizontal asymptotes. So let's start. For this lesson's memory verse, it's found in Job 42, verse 12. It says, "And the Lord blessed the latter days of Job more than his beginning." Your MVCA boosters is related to the life of Job. You need to compare his blessings in the early part of his life and also in the life after his trials. And you have the text to help you find for those blessings. So I mentioned earlier, at the end of this class, we'll be able to represent a logarithmic function, find the domain and range, and determine its intercepts, zeros, and asymptotes. Now let us be reminded that this is, there are some transformations. If you say reflect, it means that if this is P and this is the mirror, then reflect will look like this one. Next, if we say translate, we move it up, down, left, or right, like going here. If we say glide reflect, it means we move and then we reflect. Example, we glide here, then we reflect there. So these are some basic transformations. Why is it important? Because in exponential and logarithmic functions, most of them are just transformations, especially when we add something on the exponent and also on the base. Now, again, here's a logarithmic function. A logarithmic function is in this format. That's f of x equals log b of x. And remember, our base should never be negative and not be equal to 0 or 1. Our x also must be positive. And this is the form for an exponential function. Now, how could they be seen in graphs as they are in verses? You'll see the sample. This is the graph for a logarithmic function. If we will have its exponential function of base 2 to the power of x, here's how it will look like. 0, 1, 1/2, 1. This is the graph of the exponential function 2 to the power of x, while this is the graph of the logarithmic function log 2 of x. They are completely opposites, and you'll see that this is their mirror. We call it the axis of reflection. Now, how do we solve or how do we graph for logarithmic functions? One thing to do is to make use of tables, table of values like x and y. You plug the x values, then you solve for the y. Then you plug them in this graph. If your base is a whole number, like 2, it will move upwards, increasing, like the exponential. But if your base is between 0 and 1, like log of 1/2 x, then it will look like this one. That will be a sample for your graph. Now, here are some properties of Here are some properties of logarithmic functions. The first is the domain. Let me write here for the exponential. For the exponential, the domain is all real numbers, right? While the range are all positive numbers. We just interchange them. In the logarithmic function, the domain is the set of all positive numbers, while our range is the set of all real numbers. Why? If you'll check of this one, log, later. The next one, if the base is greater than 1, the function is increasing, like this one, right? But if the base is between 0 and 1, it means a fraction, then your function is decreasing, going there, sorry. Oops. Let's continue with the properties of logarithmic functions. So let me edit it first. Now, the next one is, if you notice, this is the graph of, if it's positive, if b is greater than 1, and if b is less than 1, the graph is decreasing. And what else? Remember the exponential function, it passes by 0, 1 here. But in the logarithmic function, it passes by 1, 0. So 1, 0 can be found in the y-axis. So it means that our x-intercept is 1, our 0 is also 1, and we don't have a y-intercept. Also, our asymptotes, we don't have any horizontal asymptotes, but we have a vertical asymptote. It's found at the y-axis at x equals 0. Remember the exponential function, our graph passes by 0, 1, 1b, -1, 1 over b. In the logarithmic function, you just interchange the x and the y. So it passes by 1, 0, then at b1, and the last at 1 over b, -1. Let's have 3 examples. Ready? Okay, let's have log 2 of, log 2 of x. So what is its domain? Can you tell me in the chat box, what's the domain of log 2 of x? The domain is the set of all positive numbers. Very good. For a while. My pen will not work. It's not working. Wait first, because I'm looking for my pen. This is the pen. Okay. So the domain is all positive numbers. What happened? Excuse me for a while. Let me fix my pen. Okay, so our domain will be all positive numbers. How about for the range? What will be the range? In your chat box, please, can you tell me what's the range? Very good. The range will be all real numbers. How about our y-intercept? What is our y-intercept? Remember, it will never cross by the y-axis, so we say none. You always imagine this graph. So it will not cross at the y-axis. But what is our x-intercept? Remember, it crosses by 1, 0. So our 0 of the function is also 1. Next, it will not cross. It will cross at the x-axis, right? So our our horizontal asymptote is none. But what is our vertical asymptote? Can you tell me in the chat box? What's our vertical asymptote? It will not cross at the y-axis. So the y-axis is our vertical asymptote. Let's try plotting the graph. Actually, I don't memorize the 3 points for the logarithmic function. Instead, what I memorize is only the exponential. So for the exponential, I know that it's 0, 1, 1, b, the negative 1, 1 over b. I only memorize these 3 points. So for the logarithmic, I simply interchange them. We have 1, 0, then b1. Our b is 2, 2, 1, then 1/2, negative 1. Let's plot. 1, 0, 2, 1, 1/2, negative 1. It will not cross at the y-axis. So this is the graph for the logarithmic function log 2 of x. Questions? Let's get to the next one. Okay. Our given function is log 1/2 of x. In our chat box, can you tell me what is our domain? What's our domain? All? What kind of numbers? In the chat box, can you tell me what's our domain? Very good. All positive numbers. How about our range? What will be our range? Very good. That's all real numbers. How about our y-intercept? What is our y-intercept? I get told you need, it's going down. So like this, right? So none. What is the 0 of the function? What's the 0 of the function? Very good. It passes by 1. So what is our x-intercept? It passes by 1, 0. Very good. How about our horizontal asymptote? It's going like this, right? It passes by all points, so none. How about our vertical asymptote? What is our vertical asymptote? It will never pass by. Very good. It will never pass by the y-axis. So for our graph, Sorry, I will always start with the exponential because I don't memorize the other one. Okay, so for our logarithmic function, that's going to be 1, 0, 1/2, 1, and 1/1/2 is 2. So 2, -1. Let's plot it. 1, 0, 1/2, 1, 2, -1. Here, it's decreasing because it's a fraction between 0 and 1. That will be the graph. I think the third one is no longer applicable. You can do it by yourself. And do you have any questions? Again, the domain. The domain is the domain for logarithmic functions, all positive numbers. The range, all real numbers. Y-intercept, none. It will never cross by the y-axis. X-intercept, 1, 0. Zeros, 1. For the vertical asymptote at the y-axis and for the horizontal asymptote, we don't have any. Any questions before we end today's lesson?